All right, welcome everybody to our virtual demo. For those of you who aren't able to travel to see us or have us to your lab, this is a great opportunity to, as the next best thing to see the Vega in person, is to see it on screen. So we're going to go through a couple of things today to let you learn a little bit more about our platform. The purpose of this video is to introduce the Vega imaging platform from SonoVol and to do a walk around of the device, talk briefly about it and its key advantages, as well as some useful disease applications, and at the end to show a simulated workflow using our trusty 3D printed mouse. This video is for disease researchers, drug developers, imaging technicians, even department heads in both academic or industry pharma settings that might be interested in learning more about how this in vivo imaging platform might be used by your team or teams to accelerate their in vivo studies. Maybe you're a seasoned imaging expert and want to know how this compares to other preclinical instruments or even ultrasound systems. Or maybe you've never even done an imaging study before and you aren't sure how this might be used to complement what you're already doing. Or you're somewhere in between. Doesn't matter where you are on that continuum. We are glad you're here. Look forward to get starting. In the interest of keeping this video short and sweet, we will not pack it with too much information. It's a general overview. And as always, if you have any questions, we are only a phone call or an email away, and we'd love to hear from you. Okay, well, here we are in the lab with the Vega. I'd just like to give a quick overview of what you're looking at here. This orange instrument, this is the Vega, takes up about 2 feet on the bench and sits next to a computer workstation. That does all the acquisition and analysis and all that stuff. Between the two, you'll notice an anesthesia system. You don't have to use this anesthesia. If you have your own anesthesia system, you can use that, or it's just here as an option, basically. The Vega is a non-invasive in vivo instrument. It lets you look at tiny anatomical features inside laboratory animals without harming them or the tissue. The Vega is actually an ultrasound system that uses robotics to acquire the images. You put what you want to image on top of the platform here, and underneath the membrane, the ultrasound transducer is manipulated around, looking upward at the tissue. The acoustic coupling is achieved between the transducer and the membrane with a fluid underneath the membrane. So as the transducer is moved, it's acquiring thousands of images. But since the robotic system knows where the transducer is at each of these locations, our software can automatically reconstruct these into a single 3D image. One of the questions that we most often get from people that visit us in a trade show booth or see the system for the first time is, how is this different from other systems that are out there? What are its key advantages is basically what they're getting at there. And it kind of boils down to a few key features that unlock a huge amount of benefit. So first and foremost, it's a robotic system. And that's central to this platform. It's unlike any other ultrasound system, which are all kind of modeled after clinical systems where you've got a handheld transducer and are manipulating the transducer on top of the tissue. In preclinical systems, it's the same way for the most part. These systems suffer from a few key weaknesses. Often in core facilities, these handheld ultrasound systems will be one of the most rarely used systems in the core. So why are they collecting all this dust? We think it's because the workflow can be so challenging. It takes a lot of training to learn how to use, and most biologists and researchers don't really want to learn how to be sonographers. They want to get their data and they want to move on. And sometimes that one person in the lab that was really good at using those systems, they change jobs or they graduate or they're not there anymore. So now no one knows how to use it. So it collects dust. And that's a story we've heard over and over and over. So I'm not saying it's impossible to learn how to use those systems. And if you look in the literature, people have published with these handheld ultrasound systems. But the point is, it's not really easy to use or get the data. And how is our system different? Well, there is no transducer. As you look at this, you're not going to see one. And it's because it's underneath. It's all controlled by a robot. It's more like a Xerox scanner, where you put something on it, and you press go, and you end up with your data. As a result of that, you won't suffer from this it's hard to use factor that unfortunately befalls these other ultrasound systems. So it doesn't take an expert user, and you get the same answer every time, regardless of who does the study, since it's a robot and they do things very consistently. We've heard horror stories from folks in industry that say, they have their growth curves and their technician will take a sick day and someone else will do the study and the growth curves take a dip. There's an inflection point, which is, you're not going to have that problem basically with this system because it's all automated and it's all controlled by robotics. So the other thing here that you can do, because it's a robotic system, is increase your throughput. You'll notice it has 3 bays and each has their own anesthesia nose cone, and that allows you to get through more mice per hour. And some of our users report they can get 40 mice per hour on this system. That's 10x faster than other systems. Not knocking the technicians out there, it's just when you put a robot in charge of the acquisition, the human can then be focusing on streamlining other aspects of the study, so you just get more done per hour. Next, image quality. There's a few pieces in this worth mentioning. Field of view is an obvious one. Usually ultrasound cannot be used to scan the whole body of a mouse because the ultrasound transducer width isn't wide enough, so you end up with a portion of the body that's cropped out even if you do get a 3D scan. So with the Vega you get a whole body scan that comes from these thousands of images that all become one big whole body image. That allows you to see more tissue, allows you to align these images from time point to time point and less likely to miss a detail that's important. In addition, we have a mode called acoustic angiography. This mode allows for high resolution microvasculature to be explored, basically anywhere in the body. In summary, it's a robotic system. It means less training is required, lower barrier to adoption, less risk for employees leaving or getting sick, missing a time point there. Very high throughput, so you get more science done per hour. It's a highly consistent machine because of this robotic acquisition. The great image quality, so larger field of view, less likely to overlook a pathology early in the disease progression, which means better longitudinal studies, earlier recruitment for tumor studies, for example, and excellent world-class microvascular imaging, which is useful for many disease applications. Our customers are interested in a wide range of disease applications. The Vega provides excellent soft tissue contrast, which means abdominal organs and tumors can be visualized with amazing clarity. Several customers are interested in kidney diseases, for example, where pathology can be clearly visualized and measured in minutes. Some customers are interested in immuno-oncology and drugs that they're developing in that space. And they need to precisely know the tumor volumes early on when they're tens of cubic millimeters. Calipers can't reliably measure tumors when they're that small. Several are interested in liver diseases, and they want to know the onset of fibrosis, for example, or fat accumulation in the liver, steatosis. And this is particularly true with NASH companies, people developing drugs for this disease. Some people are interested in cardiovascular phenotyping. The Vega has a nice workflow utilizing artificial intelligence to automatically find and analyze the left ventricle readouts. The list goes on and on. Any abdominal organ, pregnant animals, developmental biology, urologic applications, so even brain vasculature. If you're looking for an easy to operate platform that lets you evaluate and check in on your disease as it's evolving over time, this might be the system for you or your team. All it takes is a call or an email, and we can figure out the best path forward. It's possible that a different imaging platform may be better for your application, and we'll let you know that too. So our company exists to serve disease researchers and drug developers. And we'd love to talk with you and learn more about what you're doing and hopefully work together. So it starts with the anesthetized animal, and we can use the induction box here to place the animal in. You can do one or multiple mice at a time. It's down. You would then pull it out and transfer it over to the platform. Once it's ready, so you can take off here and place the mouse in the nose cone. It can be in either the prone position or it can be in the supine position. If you're imaging a heart, it would be like this. If you're imaging a kidney, it would be like this. If you're imaging a liver, you would put it like this. When you're coupling the animal to the membrane, you can use either water or gel, but you just squirt a little bit on there and it couples to the system. You can see as I'm waving my hand around here, it appears on the screen. So this top-down view allows you to define your regions of interest, what area of the mouse you're trying to explore. And you can also look at multiple mice at once. Here I'm placing multiple regions of interest down. This is where you get that high throughput. You can scan either all of the animal or you could scan a portion of the animal. So these are my different regions of interest that can be moved. And the user is adjusting this, and on screen here, this tells me this is where my transducer is because it's underneath the animal looking upward at the animal. And I'm able to say any small part of the animal or the whole animal can be scanned. And then when I'm ready to go, I say acquire the data. So you can see the transducers actually, this is what it looks like underneath each of the animals. You see this particular model has 2 different transducers in there. You can have multiple. One is a linear array and one allows, as a wobbler, it allows for acoustic angiography to be performed. And you can see these serial scans being acquired, these sequential scans that the robot is then tracking the position at each of these locations. The final resulting data will encompass the entire body of the animal. So that's kind of what makes this platform special and why it doesn't take any expertise to run, because it's all automated.